So here's the second type of problem that we did in 4.1, showing you again how to do it a different method. So we already showed you the answer for this, and this was under the ones that we had a graph, but let's show you how to do this with the substitution method instead. So again, first step, if possible, choose an equation that has a variable with no coefficient. That's key, no coefficient. So notice this is a little bit more complex. Notice that coefficient, coefficient, coefficient. Notice this one guy does not have a coefficient. So of course, I'm going to choose this one. So let's choose this as our first equation. So when we have that as our first equation, then what I want to do is solve for the specified variable. What specified variable am I going to choose? Remember, I chose the one that had no coefficient. So from the chosen equation, solve for the specified variable that had no coefficient. So let's underline the y because I want to get y by itself. Right now I have y minus 2x. So we know to get rid of the 2x, anything that's added or subtracted to the underline, we do the additive inverse. Opposite of a negative 2x would be to add 2x. If I add 2x here, of course I'm going to add 2x to the right-hand side. So these cancel out to give me y, and then a negative 2 and a positive 2x, hold it. One's a variable, one's a constant. So then you want to realize you cannot combine them, you have to keep them separate. Let's put the variable first and then the constant last, because typically that's how you see it. Variable first, constant last. Okay, now that you got y by itself, it's solved for the specified variable. Step 3, take the second equation. Okay, we already labeled the second equation as 3y minus 6x equals 12. And what I want to do is replace the solved variable with a plain set of parentheses. So that just means I solved for y, this y is going to become an empty set of parentheses. So 3, empty set of parentheses, minus 6x equals 12. Now that I have that empty set of parentheses, we told you, step 4, plug the expression, not the whole equation, plug the expression that we just solved in step 2. So we solved and got 2x minus 2. You're going to plug it here. Don't put y equals 2x minus 2. You cannot have double equal signs. Just this half. Because originally it was 3y, we're saying y is the same thing as this. So we're going to plug in the 2x minus 2, the expression. Once you have it plugged in, step 5, solve for the one variable that's left. Notice we only have x's, no y's, just x's. How do we solve? You remember, look at one half of the equation at a time, simplify by distributing, get rid of those parentheses, 3 times 2x is 6x, 3 minus 2 is 6 when you multiply. This is outside the parentheses, so just bring it down, minus 6x. Once you're done distributing, then what we told you to do is collect any like terms on that side of the equation. Remember, we're ignoring this side. We're only working here. Do we have any like terms? Coefficient variable, constant coefficient variable? Yes. These variable terms. Now notice I circle. I do not do additive inverses. The only time I ever do additive inverses is if I'm picking up and moving it to the other side of the equal sign. If they're both on the same side, you circle and use the signs that were given. This is a positive, this is a negative. Uh-oh, that means subtract. 6x minus 6x. Ooh, they actually cancel out. You're left with a negative 6. What's left over here? Just the 12. There's no more variables. The variables disappeared. Well, remember, if you can solve for the variable, that just gives you one half of the equation. But we're not at A now, we're at B. If all variables disappear, notice there's no more variables, it's just a negative 6 equals 12. 2 constants, no more variables. Then we're going to have to determine if you have a false or a true statement. So ask yourself, is negative 6 the same thing as a positive 12? No. These are not equivalent. This is a false statement. So when you have a false statement, then we told you your answer is not false. Your answer is going to be no solution. Just like we got it when we were graphing. Remember, these were the two that graphed as a parallel line. When there was a parallel line, we said that our final answer was no solution because there's no point that any of these two lines share the same. So you can see, it seemed like it went much quicker using the substitution method. But when I show you the third problem, you're probably going to see why I don't like the substitution method.